Hello students. Okay, let's start. Test of significance for single proportion. If capital X is the number of success in n independent trials with constant probability P of success of each trial, then we can write Ex equals to Np and Vx equals to NPQ, where Q equals to 1 minus P is the probability of failure. It has been proved that for large n, the binomial distribution tends to normal distribution. Hence, for large n, capital X n, write small n capital P in PQ, that is Z equal to x minus Ex root over Vx equal to capital X minus Np and root over Npq, where n 0 1, and we can apply the normal test. Now here is to note. Note number 1. If we have sampling from a finite population of size n, then SEP equals to root over capital N minus small n divided by capital N minus 1 into PQ by small n. And here the note number 2. Since the probable limits for a normal variate x, Ex plus minus 3 root over Vx, the probable limits for the observed proportion of success are EP plus minus 3 SEP, that is P plus minus 3 root over PQ by N. If P is not known, then taking P as a estimate of P. I said if capital P is not known, then taking small p as an estimate of capital P. The probable limits for the proportion in the population are small p plus minus 3 root over small pq by n. However, the limits for capital P at level of significance alpha are given small p plus minus z alpha root over small pq by n, where z alpha is the significant value of capital Z at level 2 significant alpha. In particular, 95% confidence limit for capital P is given by small p plus minus 1.96 root over pq by n, and 99% confidence limits for P are given by P plus minus 2.58 root over PQ by N. So here is a problem. Okay, first we write the problem. The problem is saying that a die is thrown 9,000 times. Once again, a die is thrown 9,000 times. A throw of 3 or 4 observed 3240 times, so that the die cannot be regarded as an unbiased one, and find the limits between which the probability of a throw of 3 or 4 dice. I repeat the question once again. A die is thrown 9,000 times and a throw of 3 or 4 is observed 3240 times, so that the die cannot be regarded as an unbiased one, and find the limits between which the probability of a throw of 3 or 4 lies. Okay, let's solve the problem. If the coming of 3 or 4 is called a success, then in usual notation, small n equal to 9,000 and capital X equal to number of success, and which is equal to 3240. Okay, under the null hypothesis, which we denote hx0, that the die is an unbiased one. Now we get capital P, which means probability of success, equal to probability of getting 3 or 4, that equal to 1 by 6 plus 1 by 6 equal to 1 by 3. Alternative hypothesis, we can write h1 P not equal to 1 by 3. Then we have capital Z equal to capital X minus NP by root over N capital QP. N01, since N is large. Now capital Z equals to 3240 minus 9,000 into 1 by 3, and it's divided by root over 9,000 into 1 by 3 into 2 by 3. That's equals to 240 divided by root over 2000. That equals to 240 divided by 44.73, and that equals to 5.36. Now since mod z greater than 3, then H0 is rejected, and we conclude that the die is almost certainly biased. Since die is not unbiased, therefore P not equal to 1 by 3. The probable limits for P is given by small p cap plus minus 3 root over p cap q cap by n equals to p plus 3, it's plus minus, and root over pq by n, where p cap equals to p and 3240 divided by 9,000, 0.36, and q cap equals to q equals to 1 minus p, that imply 0.64. Probable limits for population. Proportion of successes may be taken as p cap plus minus 3 root over p cap q cap by n, that's equals to 0.36 plus minus 3, and root over 0.36 into 0.64 divided by 9,000, then 0.36 plus minus 3 into 0.6 into 0.8, 30 root over 10, that equals to 0.345, and 0.375. Hence, the probability of getting 3 or 4 almost certainly lies between 0.345 and 0.375. Here's the answer.